Okay, so the table that I show you just now, I'm gonna plot on Desmos. Sorry, that's bad. Okay, there you go. Desmos is here, right? Okay. Now, if you do not know how to plot a point on Desmos, you're gonna see me do it, right? For example, the point is 2.28. Now, what you do is, well, something very similar to plotting things manually. 2.28. There you go. Right? I have just plotted a point 2, 2.28. I'm gonna plot one more. I'm gonna plot 3, 2.94. Sorry, that's bad. Aditya, you might want to eat further than your mic, yeah? Further than your mic. A bit further than your mic. Okay. Oh my, that's a very weird. Wait, that's a very weird line. Okay, there you go. Oh, this is very weird. Okay, right. Okay. So I plotted these 3 points. All right. You can see that they are not on the on exactly on a line. Yeah, they are not. Now, can you plot points on your own Desmos? Can you do that, Kyoko? Have you used a Desmos before? Sorry. I think you're muted, yeah, Kyoko?
Yes, yes.
All right, all right. Can you plot can you plot points like this, for example? Okay. Okay, give it a try. Yeah, give it a try. Go to Desmos, maybe using your browser. Yeah. All right. Then please plot these 3 points. Same thing with you, Aditya. Yeah, Aditya. So I'm asking you to do this on Desmos. Very simple. Yeah. If you cannot, please tell me. Yeah. I'm just going to show you the points, lah. Right. Right, so there are 5 points for you to plot in your own Desmos, right? The points are in the Jamboard. I'm going to ask you to plot 5 of them and tell me the result is a straight line or not. Okay, I'm going to stop sharing first, yeah? Make it easy. Right. Okay, so Aditya, are you in your Desmos, your own Desmos, yeah? Your own browser,
yeah,
your own laptop?
Yes,
right?
sir.
Are you plotting the 5 points?
Yep.
All right, Kyoko?
Yeah.
Okay. Okay, so Kyoko, do you have the 5 points?
Yeah.
Does it look like a straight line?
No.
No.
All right, you also, yeah. So that is very weird, considering that the Jamboard in the question in the Jamboard tells us, okay, it's gonna be a straight line, right? Okay, I can see that, Kyoko. I kind of agree. That looks more like a power curve. What you're going to do at this point is not to fit a line, right? It's not gonna average a line. No, we're gonna do something else. All right. Now this something else is the new thing, right? So now your calculator, please. I'm gonna expand the table into ln x. What I mean by ln x is I'm gonna take the x value and just ln it, lah. All right. So Aditya, tell me your calculator. What is ln 2? It will be not a nice number, right? It won't be a nice number. Show me. Show me. 3SF, yeah? Still cannot. Still cannot. Oh. Very nice. Okay. Okay. So in 3SF, yeah, it will be 0.693. So 3SF. Okay, Kyoko, ln 3, please. in 3SF, yeah?
Sorry, what did you say?
Press your calculator, ln ln number 3. So ln 3. Okay, 3SF.
Oh my God.
What happened? Aditya?
It fell.
Something fell?
Yeah, my phone, the stand fell.
Okay. Hopefully nothing is. Hopefully everything is okay. Kyoko, show me. Sorry, laundry. 1.1. Oh, that's almost 1.10, right? 1.10.
Yeah.
PSF. Okay, good. Aditya, is your phone okay? Is your stand okay? Are you okay?
No, not really.
Okay, take care first. Set it up nicely first. Yeah. Okay. Let's Kyoko. We go first. Lon 5, LN5, 3SF. Yeah. Give me your 3SF.
0.61.
Agree. And Lon 7. 1.95. Okay. And lastly, Lon 10. Good. Lastly, Lon 10.
2.30.
0. Right. Okay. So following the suggestion of the question, Kyoko, we are now going to make a coordinate not from x and y. No. We're going to make a coordinate from ln x, comma y. It's going to be ln x, comma y. So basically, we just use the table, but we use this number, this new one, and the y value. This new one and the y value. This new one and the y value. So you're going to make 5 more points in your Desmos, but they are now slightly different coordinates. Okay. Aditya, are you okay? Are you okay? Okay, now it's a landscape again. Is everything okay?
Yeah.
You sure? Yeah. Okay. Good. All right. Okay. So I was just telling Keiko, Aditya, I've prepared the table, expanded the table. I didn't explain why, but I want you to now plot 5 more points. The ln x, comma the y. The ln x, comma the y. You're going to ignore the original value of x.
Okay.
And tell me, what does the result look like? All right. Okay. Yes, I'm seeing your new points, Kyoko. They look more like a straight line, yeah?
Yeah.
Okay, very good. And Aditya, just waiting for your 5 points, yeah?
Almost.
Almost.
Yeah, now it's a straight line.
So it looks like it, yeah? Now, if you do this manually on your graph paper, you plot these 5 points, and then you draw the line. Obviously, currently you cannot draw, right? But if you draw that, then you will get 3 marks, right? This is the first part of the question. This might seem easy because conceptually it is very easy. It will take a lot of time to get it fast. That's not our purpose today. So I'm making it feel very easy for you so that you understand the concept, right? Because it is not supposed to be very complicated. Now, I want to explain why ln x comma y will give you a straight line. I want to explain this because it is always a straight line for AM. And the starting points are never a straight line. So one more time, if you just plot x comma y, you will never get that straight line. So you cannot continue, right? Now, look at the Jamboard, yeah? Now look at the gem. This guy is obviously not a straight line graph because a straight line graph looks like this. This you know already. Now, look at what I do. Look at what I do, right? You will recognize this from your logarithm chapter. Okay. Oh, Ainesh, I can see you now. Yeah, Ainesh, can you hear me?
Yes.
All right. Sorry. Okay. So Ainesh, I took the time to explain a new topic for Kyoko and Aditya. I think this topic is not in your syllabus, right? I checked just now, but this topic is very important for Kyoko and Aditya. Now, I want you to observe this topic just for a while because I suspect it will be important in your physics and chemistry practicals. Okay. Let me repeat this. This chapter is very unique. This chapter finds direct application to your science practicals. Correct me if I'm wrong, Ainesh. You do take chem and physics, is it?
Yes.
All right. So in practicals, this is just the normal thing to do. They make it clearer in AMAT, but your syllabus don't have it, so you observe what we're doing right now. Okay, so Ainesh, you're gonna jump suddenly to your logarithm, right? This is your logarithm. If you don't remember your logarithm, this is a quick revision of it. Okay, now for Kyoko and Aditya, you guys have done logarithm, I think, more than Ainesh. What will happen on the left-hand side, Kyoko? What will happen?
E.
It becomes, sorry? It becomes what? Sorry?
Log E.
Log, no, my logarithm choice will be log natural. That's the base. So I choose ln basically, right? There is a very good reason for that. Now, my question is, what will happen to this left-hand side? Is there anything that we can do with ln e to the power of y? Okay. So your logarithm. Okay, Aditya, how about you? What happens on the left-hand side? Any idea from your logarithm chapter? Any idea?
Kind of forgot.
Okay. Ainesh, is there any chance that you remember what happens here?
Base change? No. No.
No. Okay. ln. Okay, people, what does ln mean? It means something. It means it's a logarithm with a very particular base. What's the base of that logarithm?
N.
E. Very good. Not n, E. Because n stands for natural number. Natural number is E. I have no idea why they named it that way. I apologize for the history of matters. But that's what ln means. Logarithm with a base of E is a natural number, right? Just like pi. Do you notice that this number and this number, they don't look like a number, they are a number. Their number is the same. Look at that. The base of logarithm and the base of the guy inside the logarithm is the same. It is base E. If that happens, something good should happen. What is it? What should happen here? Anybody? Does anybody read?
You will become Y multiplied log E.
You're correct. Now, Kyoko, I will say it even better than that. What you're saying is correct, but saying even better. When logarithm E, base E, meets base E, they basically disappear. That's the good thing. They basically disappear. So, in the left-hand side, we're left with y. I just want to know who is currently confused with this. Kyoko?
No.
Clear, yeah? Aditya?
I'm fine.
All right. Ainesh?
Yeah.
You sure, Ainesh? You sure?
That log E equals to ln, yeah.
And then the fact that log base E, this E matches with the base inside, this whole thing disappear, you're just left with, that's how logarithm works.
Oh, yeah.
All right. So the left-hand side is clear, yeah? Guys, for the right-hand side, I'm going to apply one of the logarithm law. Now, one of the logarithm law. So it will look like, remember there's a times here, right? I see this ln A, blah, 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 blah. Then it will become ln A plus ln x to the power of b. Now, this is, I'm applying the simple law, one of the laws of logarithm. If you don't remember, trust me for a while. Trust me that I'm just applying the laws. You may have forgotten about the law, but that's what I did just now. Just curious, Kyoko, did you remember something like this?
Yeah.
Okay. How about you, Aditya?
Yeah.
All right. How about you, Ainesh?
Yeah.
All right. So that's the law of logarithm. This happened. I'm going to do one more thing. Y equals to ln A plus b ln x. I just apply another law of logarithm here. Huh? I just apply another one. Does it look somewhat familiar, Aditya?
Yep.
Okay. How about you, Ainesh?
Yeah.
All right. Kyoko?
Yes.
Okay, you mentioned this before, huh? Very good. Now, last thing. All this will seem weird for a while, huh? The y is the variable, right? The x is the variable, correct? Now, the a will be constant. The b will be a constant. I mean, it's not a variable. So, ln a is also a constant, right? Sorry, I put it this way. This is a variable. This is a constant. This is a constant. And this is a variable. Now, in my final form, this is my final form. I'm going to now match it with our straight line form, right? Our straight line form looks like this. Y equals to mx plus c, right? Now, I claim to you, this is the new topic, yeah? I claim to you that my final form can be drawn as a straight line. That's my claim. We start with not a straight line, and if I do this, I can draw it as a straight line. That's what happened in the table, right? Okay, so look at the match. My y is the y. Okay, now, who should my x be? Who should my x be? Kyoko.
Ln x.
Ln x, as the question tells us. All this will sound weird for now. For my straight line, I need a gradient. Any straight line requires a gradient. Take a guess, Ainesh. I know this is new, so just take a guess. Who is my gradient in the final form? Who is my gradient?
I don't know.
The gradient, let me give you a hint. The gradient is always the guy in front of the x, right? In front of the x. Well, they call it mx, m times x. Since my ln x is the x, that sounds weird, but my ln x is x, bear with me. Then my gradient is the guy in front of the ln x. Now, who would that be?
B.
All right. Okay. Again, all this will sound weird for now. Aditya, finally, who is my, C or Y-intercept in the final form?
Ln A.
Ln A. And all this will sound weird, but you are correct. Okay, yeah? Now, after I do all this, I'm going to show you the second part of the question, so you know, you kind of understand why I'm doing all this. Now he's saying something here, use your graph, right? Now, Kyoko, I will now ask you to show me your graph and I'm going to take a picture of that, okay? Yeah, good. Right, I'm going to take a picture of it. So Ainesh, we're currently going deep to this topic, yeah? Going deep, I mean, there's no other way. Just want to clarify one thing first. I did say that I don't think this is in your AMAT syllabus, but I think this should be in your chemistry and physics practical. That's the same for you, Kyoko and Aditya. Have the practical ever asked you to draw straight line graphs from your experiment, Ainesh?
Yeah.
Okay. Okay. All right. Then have the practical ask you to do logarithm, something like this. Has he ever asked you to do that?
Just a best fit line.
No, this is not. This is slightly different than I cannot say that, right? This may be different from your best fit line, Aditya. So you said that just now, right?
Yeah, like the questions just say draw best fit line.
You're talking about the practical questions, correct?
Mm-hmm.
All right. So the lines are more scattered, so the points are more scattered, not as nice as this, I'm guessing. Am I correct?
Yeah.
Maybe you're not at linear law. They call this linear law or application of Stricker. Maybe you're not here yet. I'm not sure. Right? I'm not sure. Right? Ainesh, have you tried to draw a nice line, or have you just tried to do something different, something called the best fit line? So the best fit line will have scatter points, and then you try your best to fit a line, basically.
Yeah.
Oh, that is what you did. That is what you did. Okay, understood. The linear law, which what we're learning right now, is slightly different than that. Slightly different. Slightly different. So just want to check. Okay, now people. Sorry. Ainesh, you have used Desmos before, right?
Yeah.
Right. So I'm going to ask you to plot these 5 points, because we did that already in your own Desmos, because Kyoko and Aditya has done that. Please do that, and then I will guide you through the process after that. Right? Do that in your own browser. Yeah. Okay. Okay. I'll give you 2 minutes to do that. Now, for you, Kyoko and Aditya. Okay, you're gonna fit your line. Pardon the phrase. That's not a good phrase, but you're gonna fit a line by guessing the gradient and guessing the x-intercept, by the y-intercept, right? So you're gonna type your initial guess first. Is gonna be 1x plus 2. You're gonna do that in Desmos because we don't have a paper, right? So Kyoko and Aditya, you're gonna make a curve together with a point. This is a line, sorry. You're gonna start with this. This will not be a good fit to the points. Okay, have you done that, Aditya and Kyoko?
On Desmos, right?
On Desmos, yes. You're gonna fit our line on Desmos instead of on paper. Kyoko, have you done this?
I'm sorry, what do you say?
Make this, draw this, just type this additional line on your Desmos. You just press the 6. If you go to number 6, then you can type y equals to 1x plus 2. Okay. Now for you, Ainesh, do you have some success in plotting these 5 points?
For some reason, my Desmos keeps loading.
All right. I'll kind of refresh and wait first. Okay. Aditya and Kyoko, do you have the lines already?
Yeah.
All right. Now, obviously, the line does not match our points. That's obvious. Huh? Now, the first thing that we're going to do is we're going to try to adjust our y-intercept first. So looking at the graph, agak-agak using our estimate, I think the y-intercept will be maybe 1.2, maybe. Would you please adjust this number to 1.2? So the y-intercept into 1.2. Change the number 2 into 1.2. Right? Okay, that's our estimate or our agak-agak, right? 1.2. And now you're gonna adjust your gradient until it fits all the points. Your gradient will be the number 1. Adjust this guy lah. Adjust this guy, maybe something higher until you can fit the line. If you feel that you have to adjust the y-intercept, feel free to adjust that. Look, slowly adjust. Okay, I see that Keiko is doing that. Aditya, are you okay?
Yeah.
Right. So you're going to use decimals, right? Because I think our adjustment needs to be very fine. Oh, almost there, Keiko. Yeah, almost there. Adjust again. Okay. Yeah, almost there. Oh, like that. That's very good. That's very nice. That's very nice. Yeah, that's very nice. Okay. Maybe you want to adjust a little bit more. See whether you can do that. So Ines, is your Desmos responding?
Yeah, just partly loaded.
All right. So Aditya, do you have any success adjusting the gradient?
I'm doing it, yes.
All right, all right.
I got a funny number.
Right. What do you think is the best fit currently?
I got 1.551.
551? 5, yeah, close to what's Kyoko's. And do you get any, do you change your y-intercept?
No, I kept it the same.
Right. Kyoko is giving a 5.7 kindish number, but your number and her number doesn't differ much. So I'm not surprised. This process tells you that the result is not exact. When you do it manually, it will be even worse. It'll be even worse. So this is the process, kind of, even though you're doing things manually. Right? So what does your graph give you? Your graph gives you an estimate of the M and the estimate of the C. So I'm going to write that down. The estimate of your C is 1.2. The estimate of your gradient, I'm going to take a middle value. Okay, Kyoko and Aditya. I'm going to say that's 1.56. Is that satisfactory for both of you?
Yeah.
All right, yeah. Okay, yeah. Now, Ainesh, do you have the 5 points already?
Yeah.
Okay, yeah. So that 5 points kind of looks like a straight line. Yes, Ainesh? I'm going to ask you to draw a line in order to fit all of them. Okay. I'm going to ask you to start from y equals to 1x plus 1.2. Please try that.
Okay.
You see that that is not a good fit for all the points. Yes?
Yeah.
Play with the gradient. Find your best fit lah. So you're going to play with the gradient and see how you can fit all of them. Right, Kyoko and Aditya, we're going to wait for a while. No, I'm going to explain you further because I think you guys need it more than. Now, your M is over here, right? 1.56, correct? Your C will be 1.2. That is your line. Can ya, Aditya and Kyoko?
Yeah.
Now, what this means to the question, right? This original question is that we do all that. And then your gradient, your M, is going to be equal to B. Your y-intercept is going to be equal to ln A. I'm going to write that down. 1.56 equals to B. 1.2 equals to ln A. How am I supposed to find A? This is your revision of logarithm, Aditya and Kyoko. Can I find A? Right. Now, Ainesh, how is it? Do you find any gradient number that suits the points best?
No, I'm still finding.
Okay, what is it? Sorry.
I'm still finding.
All right. All right. Go for decimals. Okay, go for decimals. Okay, Aditya and Kyoko, a bit of a revision for logarithm. How am I supposed to find A?
E to the power 1.2.
I totally agree with you. Now, whatever that number is, that will be our A, right? Now, this is what it means to use my graph, the graph that I draw, in case we use Desmos, to estimate the value of A and B. They even use the verb estimate because it is an estimate. We're just trying our best here. Okay.
1.58.
1.58 is something that Kyoko also have, correct, Kyoko?
Yeah, I like
Yeah.
change
Yes.
my answer.
To 1.5?
5.7.
All right. So let's take a middle point. Ainesh, Aditya, and Kyoko. I'm going to say that it is 1.575, right? Because everybody is just trying their best. So 1.575, right? You can stick your own number. This is a representation of our best effort. 1.575. Right, there you go. Now, everybody, I didn't explain much about this topic. I go through the motion to have you have a feel. I don't explain much. All this will feel very weird one. It is also unlikely that you can repeat this. The reason why I'm doing this is because for you, Ainesh, I'm giving you this feeling so that if this ever happened in your class, you gotta tell me. That means explanation is required.
Yeah.
Okay. If this happened in physics practical or chemistry practical, you also must tell me. This is not the best fit line. This is different than best fit line. This is better than best fit line. I would probably say that. Okay. So this weird feeling, you remember. I won't explain much for now. Same thing for you, Aditya and Kyoko. I'm just giving you a taste of how it feels. At this point, we clear the 3 marks and we clear the 4 marks. We got our A, we got our B. Now, it doesn't mean that you cannot ask any question. So maybe, Kyoko, any questions so far? Yeah, I understand everything is weird right now.
That's okay.
All right, yeah. Aditya?
Okay.
Okay, Ainesh?
Yeah.
Ainesh?
Yeah.
All right. Now, even though it feels weird, I'm going to repeat this one more time with another question. And then we get that feeling, and then I'm going to stop there. I'll get another question for everybody. Okay, Ainesh, choose between these 3 schools: Cedar Girl, Crescent Girl, or Methodist Girl. Methodist.
Ultra Methodist.
Oh, Methodist. Right. Okay. All right. Methodist. All right. Okay, now go to page 12. Okay, they happen to be the same question 7. So this is from the previous question. I just want to show you the comparison. This is the previous and this is a new one. All right, so observe the similarity between these 2 questions. I'm going to ask you one by one. What do you notice? Meaning, what similarities do you notice between these 2 questions? Okay, now read them first for 1 minute. This is the previous one that we did. This is the new one. And then I'm going to ask you one by one the similarity. 1 minute. All right. Now, Aditya, let's start from you. What similarities do you notice between the 2 questions?
None.
None? No, well, the number is not similar. I know the number is not similar, but certainly some things are similar. No, certainly.
The graph would be straight.
Okay. So in the previous question, they tell you it's going to be a straight line. since you listen to me, even though the second guy didn't say a straight line, but it will be a straight line. That's the characteristic of A math, right? So, okay, that's definitely one similarity. Okay, this one and this one. All right. Second similarity, Kyoko, if you notice any. Read it. No, there's no similarity at all. Read it. Anything, Kyoko? No.
The equation is like y equals to a.
You're referring to this equation and this equation, yeah?
Yeah.
Right. They are not the same. I understand. They are not the same, but they kind of maybe look similar. Maybe lah. Actually, they are not the same, but maybe they look similar. You're going to see later, everybody, that I'm going to treat it the same as just now. Okay, that's a good point, Kyoko. How about you, Ainesh? Do you notice anything similar?
Yeah, this two.
All right, what would that be?
They're switched around.
Sorry, did you say? What did you say?
I can't remember how it is.
You're referring to the what? You're referring to?
Indices.
Oh, yeah. I mean, we are starting with indices. Yeah. I agree with you. We are definitely starting with indices. That's why this guy and this guy looks similar. I want to enhance your observation, Ainesh. You would notice that the first question have A and B as constant, right?
Yeah.
The second guy, even though the equation is not the same, but also A and B are constants.
Yeah.
Can I say that? Right? Can I say that? Furthermore, variable xy also. Did you notice that?
Yes.
Good job. Right? So notice the similarity, people. This is just a general pattern of this topic. Right? Maybe a few more similarity. Maybe Aditya. Maybe you can see more now. Maybe. What do you think, Aditya? Anything possible? Anything similar? Nothing similar? No. Okay, I'm gonna see whether this is similar or not. Remember, people, we try to plot the original points and we didn't get a straight line, correct? So Aditya, Kyoko, and Ainesh, I'm going to repeat that. Plot this 1,4.8, blah, 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 blah. See whether you can get a straight line or not. Okay, please try that in your Desmos. Right? At this point, you can do this in 1 minute. So please try that. Okay, how is it, Ainesh? Do you have the 6 points? What do they look like?
Putting them in.
Sorry, what are you saying? Sorry?
I'm still putting them in.
Oh, right.
I'm going to have to cancel everything else.
Aditya, how is it? Do you have your 6 points? Hyoko, how is it? Do you have your 6 points?
No.
I can't see how they look, but do they look like a straight line?
No.
All right. Okay, they don't. Aditya?
No.
All right, doesn't look like it. And Ainesh, to confirm, does it look like a straight line?
No.
All right, people have an understanding. That is what we expect. Just use the table. We will not get a straight line. That is the expectation. This topic is about making something not straight become straight. This is the whole point of the topic. That is why the topic becomes very practical in practicals. Maybe you understand later. What am I supposed to do to make the plot straight? Am I supposed to best fit Aditya?
No.
All right, Kyoko, best fit? Is that what we're doing?
No.
What am I supposed to do then? Any idea? Ainesh, Kyoko, Aditya, what am I supposed to do?
This looks like a quadratic graph.
It kind of looks like it, but it's an illusion because the original equation is not quadratic. I mean, it's not a bad idea, but it is an illusion. That one I can guarantee. It's more like a power graph. It is more. Now, what am I supposed to do? Usually the question tells me. The question is very kind one. The original equation, they tell you ln x. They actually tell you. We just have to follow. What does this new question tell us? Do we change the x?
No.
No, because the question is very kind. We follow the question, won't sabo us. Ainesh, did the question tell us to change the y? Did it?
Oh.
No, he did. Look, log y. That's what the question takes. You're not going to use y. You're going to use log y. That's what the question is telling us. Okay, so let's try that. Okay, so Aditya, Kyoko, and Ainesh, you're going to just manually do this. Right? You're going to press the calculator LGY for the y value and tell me what the values are. Right? Okay, everybody, please do that. This is like a manual work, right? Okay, Aditya, right? Once you're done with your origami, tell me what is LG 4.8? 3SF.
0.68.
Okay, right, 3SF. Right. Okay, continue, please. Kyoko, what's my LG 9.6?
0.982.
0.982, yes, 0.982. Yeah. All right, okay. Aditya, Ainesh, what's my LG 19.2? No, this is a number. 3SF, please, yeah. With calculator, of course.
Yeah.
All right. What would it be? LG 19.2.
Hello?
Yes, yes, Ainesh, can you hear me? Ainesh, can you hear me?
Copy.
Okay. It's severely cut off, but I can hear you speak to me.
Yeah.
Can you hear me? Okay, better. Ainesh, testing. Ainesh, can you give me LG 19.2?
LG.
Yeah. All right. In your calculator, there's basically that's LOG. In your calculator, there's LOG. Okay.
Yeah.
All right. Please give me that.
19.2.
Yeah, LG 19.2.
It's 1.28.
Sounds about right. Good. Aditya, LG 38.4.
1.58.
Sorry.
1.58.
Right. 1. Oh yeah, 1.58. Good. Kyoko, LG 76.8.
1.89.
Okay, last one. Ainesh, LG 153.6.
2.19.
Okay, now looking good. In your Desmos, what are you supposed to plot, Aditya? In order to get a straight line?
Sorry?
In order to get a straight line in your Desmos, what are you supposed to plot? The question tells us. That's how the question works.
Oh, so
are we supposed to use the x?
Over 0.1? I think.
No. So the question tells us, draw the graph of LGY against x. Basically, it's telling us, use the x and use the LGY. Just to be clear, are you at page 12? Is everybody at page 12 or Jamboard? Just checking.
Yeah.
Yes.
All right. So you are not going to use the y. For now, well, because the question they asked is very kind in doing that. So you have your 6 points, people. Now this is a new 6 points. Does it look like a straight line now? Please do that. Ainesh, same thing, yeah? Okay.
Little.
Yeah, much better, right, Kyoko? Much better. The last one might seem a bit off, and that's quite normal. Kyoko, can you now make an estimate of the C and the M? Do you understand what I'm saying? Same process as just now, lo. Estimate the C, estimate the M. Lo. That means we're trying to fit a line through everything. Can? Okay, give it a try. Aditya, do you have the 6 points? Does it look nice?
The last one is a bit off.
A bit off. I agree with you. That's kind of normal. That sometimes happens. One of them, right? Can you now do the fitting of the line, guessing the guessing the intercept, guessing the gradient?
Okay.
Same as just now. All right, give it a try. Give it a try. Yeah, Ainesh, do you have a 6 points?
Yeah. The
All
last
right.
one's a bit odd.
Which is kind of normal, something that you can expect to happen in exam questions, but just one, usually not more than one. And it's only a little bit off, right? Yeah, just to give us a sense of realism. Can you fit the, can you do the fitting process again? Guess the C, guess the M? Like just now. Just now I give you the C, I ask you to guess the M. Now I don't give you anything. Try to guess yourself, right? Give it a try.
Yeah.
Okay, Kyoko, you have to start by typing lah. Because in this case, we're not drawing things, we're typing the y equals to some gradient x plus some number of c, right? And then we start from there. We start from guessing from there. That's the process. Okay, let's try 0.4 and then x. Okay, sure, right? Start with some number first, right? Make a guess of what the c is. Okay, now that's your guess, lo. Then you start from there. You're going to change the M, you're going to change the C until it kind of fits. Okay. Aditya, how is it? This is harder, yeah? Because I didn't give you the C. Are you okay?
Yep.
Kyoko is getting something. Good. Kyoko is getting something. Good. Yeah, you can use a ruler. That's actually not a bad idea, Aditya, yeah? Not a bad idea at all. What do you think, Ainesh? I don't give you the C, so this is harder to guess. Are you okay?
Yeah, I mean, I'm doing it on the same laptop as my Zoom, so I can't like use the ruler or anything.
Interestingly, you can use the ruler on your screen to guess the C, if that makes sense. That helps you guess the C on the screen, like a physical ruler kind of thing. That does help.
True.
Right? You can try that. You can use anything which is straight. Right? Kyoko is fine tuning. Good. Kyoko is fine tuning. Oh, that looks bad. That looks quite good, Kyoko. That looks quite good. If you're satisfied, you tell me. How is it, Aditya?
Oh, I got it. I think.
Yeah. All right, Ainesh. Give me some numbers. I can have a sense whether it's correct or not.
Mine is y equals to 0.3 x plus 0.4.
That sounds about right. Quite happy. What do you think, Kyoko? Do you have what numbers do you have?
Y equals to 0.297 x plus 0.4.
0.4. Very similar to Ainesh, right? Very similar. I can see that. What about you, Aditya? Any good guesses from you, Aditya?
Am I on mute?
No,
No,
sorry, did you hear? Yes.
Yeah, I
Yes,
I
Adi.
got the same as Kyoko, 0.297x plus 0.4.
297, right? Now, in reality, we probably, when we do things manual, we probably won't be getting 0.297. We'll be probably getting something closer to this. So all of you did a very good job. Yeah, obviously, all of you agree without discussing with each other. Very likely that you're correct. Okay, I'm gonna do the last thing. I'm gonna give you the feel. What am I supposed to do? Okay. Y equals to ABX. Out of nowhere, I'm going to learn the left-hand side and learn the right-hand side. This is again a revision of your logarithm rule. Kyoko, what happens to the left-hand side?
Sorry, what was it? Oh,
Yeah, on the Jamboard. Yeah. Okay. Out of nowhere, I ln. I'm sorry, I am not supposed to ln. I'm supposed to lg because the question tells us already lg. Now, what happens to the left-hand side?
not 10, 1. Yeah.
Correct. Which is to say, nothing can happen though. It'll stay as lg. Why? Can? It'll stay like that. Now, Aditya, what happens on the right-hand side? Any idea?
It becomes. I think it becomes x log AB.
No. Well, the LG will be there. The application is not exactly correct, but you're right to say that later on the X will detach. That is correct. That's correct. Yeah. I'm going to remind you. I just want to remind you the law later. Ainesh, any guesses on what happens on the right hand side? Any guesses?
No.
Logarithm law, right? I'm going to do the logarithm law again. It will not make sense, people. Logarithm law does not make sense. I'm so sorry to say this. You have to memorize it. Okay. So what will happen is this is a times. Since this is a times inside the logarithm, this LGA plus LGB to the power of X. Why is this making any sense? It's not, but it is going to be correct. Right? Okay. Yoko, can something happen to this guy?
It becomes X log LGB.
Good. You're correct. The rest don't change. Again, that's another law. So I'm just using two laws here. LGA plus I'll just write LGB times X. Okay, just make it clear. Now, why the heck am I doing this weird logarithm step? Because I can now match. I can now match this with my graph. Remember, this comes from the question. This comes from my graph. I will now match them. Okay. Now, this is the easy one. X match with X. Right? That's the easy one. Kyoko, who does LGY match with? Who does LGY match with?
Y.
Very good. That's so weird to say, I know, but it is correct. Ainesh, who does 0.3 match with here? Who? Who does 0.3 match with here? There are only two candidates, by the way.
The first one, this one.
The LGA?
Yeah.
LJ. And however, I would like to remind you that 0.3 is in front of an X. Means it is attached to the X. Whereas LGA does not have any X. You may want to reconsider. No, this is so weird, but you get what I mean? The X is here, the X is here. The 0.3 might not be LGA, but instead it might be
The second one.
the LGB, just because it is attached to X. That's my only argument, right?
Yeah.
This will feel so weird, but that will be correct. And finally, to finish up, Aditya, who will be my 0.4b? 0.4 will be who?
C.
Sorry, 0.4 will be, sorry?
The the C.
He said LGB, I think.
No, not LGB. No. Wait, guys. Okay, I know this is confusing. I really know. Yeah. Okay, but bear with me. This is X. This is X. That's why 0.3 is this guy. That's Y lah. Right. This plus that.
So be
This
LGA.
plus that. LGA. Yes. Okay. The order doesn't matter. I can switch it up. So LGA will be 0.4. As weird as this sounds, you guys are correct. Oh, I'm so sorry to do all this to you, right? Okay, so right now we have LGA equals to 0.4 and we have LGB equals to 0.3. I'm supposed to find A, I'm supposed to find B. People, what am I supposed to do to find A and B? Your logarithm revision, please. What am I supposed to do? Yes, Kyoko?
E equals to 10 to the power of 0.4.
Very good. And B, Aditya? B?
It will be 10 to the power of 0.3.
Yes. Although you sound doubtful, you are correct. Ines, logarithm is your arch nemesis, yes?
Yes.
Your arch nemesis, if it is gone from your syllabus, like as in this, if this topic is not in your syllabus, then I suppose good for you. We only have the logarithm topic. That's why I say the moment you see this guy appear in your math class, better tell me lah. Okay?
Yeah.
If you don't have it and you don't use it in practical, I suppose good for you. But for Kyoko and Aditya, definitely this will appear. Now, when this truly appear in your class, when your teacher finally discuss this, what do you do, Aditya and Kyoko?
Cry and wave desperately for help.
Oh, tell me. I will start explaining the meaning of all this. Just tell me. So that we are more advanced in class, right? We are more advanced in class. Understand, Kyoko and Aditya?
Yeah.
Right? Just tell me, oh, that thing starts already. Okay, let's get ahead. In this 1 hour, yes, Kyoko, yes.
What is this topic?
I cannot hear you very well.
What is this topic?
This topic in your textbook is called application of straight line, also known as linear law. That will be your chapter 9, no? Right? So I don't think it will be.
When I go back to school, oh God.
Looks like that's gonna be it, Aditya. And logarithm will be, part of your menu again. You understand why I'm now giving you this at least 1 hour as a feel, okay?
Yep.
Right. Now, again, for you, Ines, I hope you don't have to deal with this. But if you do, please tell me immediately.
Yeah.
Okay. All right. Okay. Now, we spend a lot of time. Let's summarize what we did. Let's summarize what you did in holiday until now. Ines, this includes the sessions before your holiday, before your trip. Okay.
Yeah.
What future topics have we talked about? All right, let's just summarize one. Okay. Let's summarize all the future topics. We are going to page 13, by the way. Okay. Now, have we talked about arc and sector? Aditya, Ines, and Kyoko. Aditya?
Yeah.
Yeah.
Good, Ines. Okay. And Kyoko, have we talked about it?
No.
Oh, you didn't attend yesterday. Right. Okay. Understand. Right. Okay. No worries. This will be your email. For you, Ines, whenever I say email, just ignore me. Do you know why?
Yeah.
Right. Because they have. So email, Aditya, to you will be your international math, is it? Something like that? International.
Yeah, but we just call it email.
Email. For Kyoko, right? You will have this Ines, definitely. Now, your sine rule and your cosine rule. Have you discussed that with me, Aditya?
Yep.
Right. Now, Ines? A sine rule and cosine rule. Does that sound familiar? Are you sure we discussed about that already? Wait, it's not sine and cosine,
Wait, what?
It's not sine and cosine. This is more advanced than sine and cosine. Sine rule and cosine.
Is it the inverse one?
No, definitely more advanced than that. Now, this is what you miss when you got back from your trip and you were sick back. That's what you missed, right? Kyoko, we did that already. Okay. Now the A mat trigonometry, which is totally different than. Have we discussed your A mat trigonometry, Aditya?
Yeah.
The exact numbers and everything. Ainesh, we did some, I suppose, right? Yes or no?
I mean, I don't know what AMAT figure refers to.
A mat trigonometry will be your what happened yesterday with Aditya. All the graphs, all the sine 163 degree will be equal to sine 17 degree will be equal to minus sine 197 degree, that kind of thing. We covered this yesterday, something like that. Did we cover that, Ainesh? No, you don't remember? No idea. No idea.
I don't know.
Wait a minute. Let me check that with you because you'll be facing this very soon, right? Very, very soon, Ainesh. This one is your urgent need. Kyoko, we did that already, yeah? Kind of, yeah? Okay, now what else we discuss? Just now, we discussed something just now. That's called linear law, linear law. Okay, so we discussed that even though it's not a lot. We also discussed coordinate geometry. All right, Aditya, we did that. Okay?
Yep.
Coordinate geometry. Ainesh, we also did that. And Kyoko, we also did that, yeah? Coordinate geometry. Okay. Now, what else did we discuss? I know Kyoko, we discussed one more at least. What is it? The first one that we discussed.
Binomial theorem.
Yeah, whatever that is, binomial theorem. Binomial theorem. Did we discuss anything else, Aditya and Ainesh?
No, I was only for 2 weeks. So
I think no. So yeah. How about you, Ainesh? Did we discuss anything else in preparation for next term?
I don't think so.
Right. Now your greatest need.
we did like the circular measure, the arc sector.
Oh yeah, we did. I mean, a very small portion, but we did that. See this one. Okay. Yeah. Right. Anything else?
Nothing else.
Right. Now, whenever any of these topics start, you tell me. That's what I mean. We cover them as introduction. You will be able to understand your first few class. You may even find them easy. Doesn't mean that you're exam level. No way, man. Right. So for you, Ainesh, your greatest need is this. Oh my goodness. Okay, so let me just confirm. Tomorrow, everybody can attend. Am I correct?
No,
Yeah.
I can't.
Wait, Ainesh can, yeah? For 2 sessions, right?
Yeah.
Right. Aditya, you cannot attend for both sessions?
Session.
All right, so only one in the afternoon. Right?
I mean,
and then
afternoon session.
Afternoon session. And Kyoko, you can attend both.
Yep.
Yeah, all right. Okay, I think I know what to do. Today we're going to end early, no homework needed. All right, and I'll see you tomorrow. Tomorrow for you, Ainesh, we will be making up for AMAT trigonometry. That is your greatest need if you see your AMAT syllabus. Okay, you miss that and we need that. Like that's yeah, basically. Right? So Ainesh, don't leave first, only Aditya and Kyoko. Okay? Right? So Kyoko and Aditya, I will see you tomorrow.
Okay. Bye-bye. Thank you.
Bye-bye. Thank you.
Thank you.
Okay. So Ainesh, your syllabus will be the AMAT trigonometry. Now, to dispel any doubt, I'm going to show you your syllabus one more time. I'm going to share my screen here. Share my screen. Where is okay. Ainesh? Right. So, all right, here we go. Right. So Ainesh, for your term 2, the ones that they haven't covered, this is what you call your sine rule and cosine rule. Wait, is it? Oh yeah, there you go. The sine rule and cosine rule. I'm pretty sure they haven't covered, and I think you missed it also from our side. Okay, that's your sine rule, cosine rule. This is still a sine rule, cosine rule. This is your arc and sector we covered before holiday, before trip. And then your, what I call the AMAT trigonometry will start from supposedly week 2 lah, week 2, all the way until, my goodness, until week 9, no? Right? Something like that. So that will be your AMAT trigonometry.
Yeah.
Right? Okay. Look at the Jamboard, the same Jamboard. Look at the same Jamboard at page 3. I'm gonna give you a feel of it first so that tomorrow you can catch up more quickly with us. Right? Are you at page 3?
What was this?
Let me explain. There are currently only 3 things here. I only show you 3 things. I'm showing you the graph. Oh, that's it. The graph. I'm showing you a table, and I'm showing you formula. Let me give you the good news first. The good news is formula looks super weird, the weirdest of them all. You don't have to memorize. You just have to use. I'm just teaching you how to use them. This will be given in most people's exam. Your school might be a crazy school. Maybe your school don't give it. Maybe. That's your school. When your teacher says something that this is not going to be given in your exam, you tell me immediately your school is behaving like your school.
Yeah.
I hope not. I hope not. I'm going to assume at the start that I'm just going to teach you how to use them. Now, this will be later, so you forget about this one. I'm going to draw your attention to the table. The table might not make a lot of sense right now. I am going to, well, ask you to memorize. Okay. Look at this table. This table contains 5 angles. Okay. These 5 angles are an obsession of what you call the AMAT trigonometry. For you, it's just trigonometry, right? Why are they obsessed with these 5 angles? Because the result of the sine, the cosine, and the tangent are rather nice number. Personally speaking, Ainesh, do you think this is a nice number?
No, not really. I mean,
I wouldn't. Yes, you're saying yes.
As a fraction, yeah, but as a decimal.
Yeah, in fact, they might look a little bit ugly or a little bit intimidating because of the circle. I would agree with you. This one even worse, right? This one even worse. None of them look particularly nice until you press the calculator, right? So try to press cosine 30 in your calculator. Let's see what happens.
I got 0.87.
Yeah, and you know, at 0.8, it's actually 66, isn't it? Right?
Yeah, 0.866.
I forget. Since we're only 2 of us here, I'm going to stop our sharing and just refer to your Jamboard. You don't need to refer to the Zoom. So are you at the Jamboard instead? Okay.
Yeah.
Now, here's the thing about this table. Because of their obsession on exact number. Exact number is what they consider nice. Your decimal is not nice to them. It's not exact. Now, I invite you to press your calculator, half root 3, and confirm that that is exactly the same decimal as your cosine 30. Please try that.
Okay.
Okay, they are exactly the same. I'm not bluffing you, correct?
Yeah.
All right. So the deal with this table is this, Ainesh. I told everybody this. The moment they show you this table, this is one of the first things they show you in the AMAT part, so to speak. You may no longer use your calculator with these 5 angles. You may not. You must instead give them these supposed nice numbers. Because they are very obsessed with nice numbers. Now, this has a few implications. If they ask you for sine 44, do you use the table or not?
No.
Very good. What do you use?
Regular calculator.
Because it's going to be ugly.
Yeah.
That's what it is. That's the deal. So now one of the first things I teach them, right, in the video, now I teach you, is how to memorize this very easily, because it's that important. They are very obsessed about this. Whenever you have exact, they will demand exact. That's how it is like. So observe how I teach you, right? So we're going to ignore the cosine. I'm going to erase that. You're going to use your paper, by the way. We're going to ignore the tangent. They are not very important. Also, we're going to notice first that the first thing you memorize is sine 0 is 0 and sine 90 is 1. Can you do that? Easy peasy? Can?
Yeah.
Right. And I'm asking you maybe a bit more than usual, but I want you to like immediately memorize them, not later. Sine 0 is 0, sine 90 is 1. Okay? Sine 90 is what?
1,
And sine 0 is?
0.
Very good. Now, memorize the three other angles, 30, 45, and 60.
Now?
Oh, now. Yes, now. In fact, I've already erasing them. Tell me, what are the three angles?
The 30, 45, 60.
Oh, very good. As expected, your memorization is not bad, okay? It is not bad, right? Now, let me guide you even further. Memorizing the three numbers are extremely easy. Observe. Half root 1, half root 2, half root 3. No explanation why, but you know, it's not that hard. It's really not that hard, you know. Okay, you're just putting it in your mind. Huh? You're not going to put it on your paper, so to speak. This is in your mind. That's not 1/3. It's 1/2. 1/2.
Okay.
1/2 root 3. 1/2 root 3. All right. Now, here is the good news. Here's a good news, Ainesh. We finished.
One second. Isn't this just half?
Yeah, everything is half. Everything is half. Oh yeah, half root 1 is half. Do you know why I put root 1 here? No, you're absolutely correct. Half root 1 is only half. Why? To make the pattern obvious. That's what I'm doing. You don't have to write the root 1. I'm just saying that the pattern is obvious when you see it as root 1. That's all I'm saying. Okay? Obviously, your teacher will only write half. Okay? I'm making the pattern obvious here. Okay? No problem?
Yeah.
Okay. So now, here's the... Oh, my goodness. Right, I made a mistake. Right. Okay, here's the good news. You no longer need to memorize. Let me show you why. For cosine, I mean, for cosine. The cosine is just the reverse of sine. That's all. Okay, wait on. So, yes, 1, yes, then 1, then?
So 1, then half square root 3, then half square root
Yep, and then?
root 1, and then...
Yep, most excellent. Now I'm going to write them all. There's a reason why I write them all. Is because now tangent. You may know or you may not know, but tangent is always sine of that guy over cosine of that guy. That's always true. So for example, sine 30 is tangent 30 is sine 30 over cosine 30. Just treat this as memorization for now, okay? Now, what does this mean is that we don't have to memorize the tangent value anymore. It's now just calculating. What is 0/1?
0/1 is 0.
Very good. Nothing divided by 1, still nothing. Ding dong. Let's go to the behind verse. 1 divided by nothing. Now, what would that be?
1.
Definitely not. This is super weird. Let me remind you, this is super weird. This is what you experience in your function and everything. This will be infinity, also known as undefined. If this is weird, we're going to postpone the discussion. 1 divided by 0 is infinity. Just press your calculator. Your calculator will tell you something. 1 divided by 0 is?
I got a math error.
Which is his way of saying it's too big.
Yeah.
That's his way of saying. So it's infinity. It's not 1, it's not 0. We're going to save the discussion for later. Now, let's look at 45. 45 is extremely easy. It's this weird guy, right, divided by himself. That will be equal to? A weird guy divided by himself will be equal to? You're not
One.
supposed to press the, yes, very good. You're not supposed to press the calculator. This is logic. Oh yeah, himself, go by himself, one lah. Surprisingly, the other two is also very easy, It's very easy one. Half root 3 divided by half root 1. I mean, the half cancel each other one. Correct? The half cancels one. So it's just root 3 lah. Correct?
Ah.
Easy, right? The other guy, that means also easy. I just 1 over root 3. That's it. Look. Can you accept all this?
That means then sine divided by cos equals tan.
That is always true, not just for this
why?
5 angle. Oh, very easy to explain. Okay, I'm claiming that this is always true for every angle. All right, not just this 5 angle. Okay, just to be clear. So, for example, isn't sine what you learn from then is, remember, it's opposite over hypotenuse. You learn that kind of, yeah.
Yeah.
And that cosine is
Cosine is base over hypotenuse.
adjacent. Yeah, base. I call it adjacent. The formal name. And that tangent you will remember is
Opposite over adjacent.
Now let me ask you, O over H divided by A over H, what does it become?
I don't know. I've never had 4-level divisions. I've only had 3-level divisions.
Nonsense. You did this in primary 5. Let me remind you. 2 over 3 divided by, let's say, I don't know, 5.
Switch around. Yeah, switch around. Yeah, okay.
And you 2 over 3 times 6 over 5, right? Okay. You have it from that. So O over H
And H
divided by A over H equals to O over H times H over A equals to over A. And that's why it is always correct. Now this is very useful to know. We'll be using it from a lot of time actually. Would that be okay?
Yeah.
Right. So now back to the table. The table is my first introduction to you. You need to memorize this by heart right now. I will erase this whenever you say ready. You will then write on your paper. Are you ready?
Okay.
Ready? Are you sure? You ready? You're gonna make this table in your paper, okay?
Okay.
Ready?
Yeah.
All right, go for it. Go. Excellent angle. Sine first. A good habit is sine bracket, cosine bracket, tangent bracket. It's always sine of something. It's always cosine of something. No. The bracket is in front of the sine. Sine bracket. I mean something like this. Sine of something. Cosine of something. That's what I mean. Tangent of something. This is always true. You shouldn't just write sine or cosine or tangent. Just for formality, okay? Formality is that. Okay, let's start from the top one. Done. The 3 middle guys are easy.
Then after that, it's half the one.
Yeah.
Then half the one.
Yeah. All right, tangent.
Okay, then now it's infinity.
Also known as don't have or not defined. Then.
Yeah. And then after that, over here is
Nothing divided by 1. Nothing divided by 1.
Is nothing.
Correct. Nothing divided by 1 will still be nothing. Correct. Then
Divided by this is 1 by.
the half cancels. The half cancels.
Yeah.
This will be correct. Then, okay, voila, got it.
Oh,
Okay, and have this at heart. However, even if I say that in exam, you're gonna write this down first, low. You understand?
yeah.
Oh, exam start. Just whack this table and then you have it for your reference. Why think too much? Understand?
True.
Your sign is not H over O, it's O over H. It's so. It's so. So katoa.
Sign is
Sign OH, SOH. So ka.
cross is over hypotenuse. Sign is opposite over base. Over divided by let's go. Okay.
Oh, all right. You still have a lot to catch up in order to benefit from the tuition. I will see you tomorrow.
Yes.
Good job.